All right. Thank you everybody for being here. So in the next around 45 to 50 minutes, I'd like to give you a brief introduction about TypeScript, so of the more advanced stuff. So quick show of hands, how many of you are using TypeScript? Nice. Okay, so hopefully I can show you something more advanced with it. So quick introduction to myself. Who am I? My name is Woerz. I'm working in the industry since around 12 years. Started with Java, and then 7 years ago I've started using Angular, also TypeScript, and then I've just followed like the journey of TypeScript until today. You can scan this QR code if you'd like. You can then go to my website. You'll find all the code on my GitHub, which I will show you today, so you don't have to take any pictures. Of course you can, but it's on there so for you to copy. And you can also find my Twitter, my LinkedIn. If you have any questions after the talk or anywhere later, just send me a message and I will gladly have a chat with you. So when should you ask questions? You can ask them anytime. You can scan also this QR code. You will then come to a website, and you will also see this QR code during my presentation, so you can always scan it. And you will then come to a website with a Q&A where you just can put in your questions, and after the talk we have around 10 minutes I think left, where I then can answer all the questions, because it's much easier I think for you also to see the question than if you have to shout it through the room. So yeah, let's get already started with the expedition with live coding. So we will talk about 6 different topics today, but before we start, I'd like to give you a brief introduction what will happen here on screen. You can, on the right side is like the agenda, what we will talk about today. And the special part about this is that it's this is an extension I've written in VS Code, which only displays which checks your TypeScript file and searches for a result, and then it displays the value in this little window. So as we can see here, I have this to-dos app, basically, and this is only written in types. So if you would compile this to JavaScript, there will be no code inside the JavaScript file because there are only types. And it's also interactive, like you can, for example, say, I want to change this to a 2, and now we see this now as a burning symbol at the map types, so we can get started with this one. By the way, this QR code is for the questions down there, so just scan it if you'd like to ask a question. So let's get started with map types. So let's say we have an events type here. And let's say this has an add property and a remove property. Now, let's say we have a user actions here, an object user actions, which has the onEvents type. And we want to have, like, for each of the events, we also want to have like an on methods. For example, on add, we want to have a function. And for on remove, we also want to have a function. Now, the problem of this is, let's say we want to create like our on events type. We could create it like this. We could say on add, which is a function of type any, and on remove, which has basically the same. Now, this works fine, but the problem here is that it's not connected with each other. So if I change the events, then the on events will not change well. It will just compile. So if I say, for example, I have this move string here, then the on event still works, but I really wanted it to also be reflected in the user actions. So how can I make these dependent on each other? We can use so-called mapped types. So what we can first say is, I create an event keys type, and we say in the event keys, I only want to have the keys of the events. And what this does is, if I now check the event keys here, it's only allowed to have the add, move, or remove property in it. So this is a good way to start. So what we now can do is, we can remove these properties here, and we can use so-called mapped types. So what we now can do is, we can say we have our key. This key has to be in event keys. And the value, basically, we don't care. It's just any function. And now we can see we have created a connection between the events and the on events. So now we have to rename this to add and to remove. And now, as we can see, user actions does no longer compile because we are missing the move property. So this way we have connected these two with each other. Now the problem is here that we are still missing this on prefix and the uppercase first letter. So how can we fix this? We can map over our keys. So we can say as, and then we can use template literals and can say, for example, we have an on prefix and use our template syntax and can then say key in there. And now as you can see here, we now have to add, on remove, and on move. And now it works again. So now we have like created new types from existing ones, but what we still have to do is we have to uppercase the first letter. So because TypeScript knows that we have to do this often, it provides a so-called intrinsic function. So we can use capitalize, which we then pass our key, and this way we now have our keys capitalized like this. So if we check this capitalized, we can see that this is a so-called intrinsic type. What this means is this is done by the TypeScript compiler. We don't really have to care what it does because it's done so frequently that TypeScript decided that it will do this under the hood for us. We don't have to care about this. So this is how we can use the map types, and we will see also how these template literals work in the next topic. So we will now talk about the template literals and how you can use them to make your life much easier. So let's say you have like a chessboard, let's say, and we want to have each of the positions of a chessboard as a type. So for example, A1, A2, and so on. You could write it like this. You could write it A1, and it's gone. Could write A2 and so on. But this is quite repetitive because you would have to do this like 64 times. So what you can do instead is you can let TypeScript do this for you. You can say we have a chess letter here, and this is either a or a B or a C and so on. And we have then a chess number here, which is either a 1 or a 2 or a 3 and so on. And now we can use the template literals. We can say we have our chessboard here, and we have the backticks, and we can say the first element is our chess letter, the second element is our chess number. And now TypeScript creates for us all possible permutation of these types. So the cool part about this is if you decide, oh, I want to just add another character or something like this, then it will just create them for you, so you don't have to take care of this yourself and like see, have I created every possible type. So by the way, I get often asked what this plugin here is. This is called 2/ queries. You can also install it in Visual Studio Code, and then you can just add like this arrow, and it will show you in your code what your type is. That's really nice if you if you want to show somebody, or if you don't want to hover over it all the time. So, but chess letters are not really, and chessboard you are not really using on a daily basis. So let me show you something a little bit more real life. So let's say you want to like check that a string has a certain shape. So let's say we have an RGB CSS type here, and let's start with it being just a string. Now let's say we have a valid CSS here, RGB CSS here, and this is now just a normal string, but it starts with RGB and has these values in it. Now let's say we want to have let's copy this and make this an invalid one. So remove, let's say the last property, and we now have an invalid one. Now we say here this is an RGB CSS property, and now of course this is still both completely valid because it's just RGB CSS is just an alias for string. There's nothing special. But now we can use backticks. What we now can do is we can use the backticks like this, and we can say it's prefixed with RGB, and now we can say the first element has to be a number, the second element also has to be a number, and the third one too, like this. Now as you can see here, we now get an error. We now get an error here at the bottom of this invalid RGB CSS. Why? Because it does not fulfill this pattern we've seen here, which we decided to implement. So if I now would, for example, add an A here, this will also no longer compile because this is not a number. I would have to change this to string to make this valid again. So this way you can like narrow down your string types to so that they have to be in a certain shape. For example, if you like to build a domain-specific language or something like this, you can use this really well to build like your own types, and even in the primitives. You don't have to like have wrapper objects, or like you can't just do this with objects, but as you can see, template literals are really great for strings. So let's combine these template literals with map types, and let's keep it a little bit with the CSS. Let's say we want to have like a margin padding and every possible combination. So let's say we have a gap type and we say this is either margin or padding. And now what you can do here is, let's say we have a positions too, and we say left or right or top or bottom. And now we can create our gap CSS here. We can use backticks again, and we can say we want to have the gap type followed by the positions. Now what we also want here is that we can have only margin or padding, like this short way of writing this. We can just do this by saying we want gap type as its own too. So now what we want the sizes to be exactly how we want them to be. So we have our size type, and we want to have either, for example, rem or m or pixel, or we want also to allow empty ones, because, for example, if you have a width 100, then you don't want to have like a suffix of a type. And now let's say we have our size CSS here, where we can have a number as the prefix, and then we want to have our size type in here. So now we are ready. We can now create our own margin padding type with the map types. So we can have our margin padding here, and we can say again our key has to be in gap CSS and the value has to be size CSS. And now we have our margin here of type margin padding, and we now can check what the auto completion is. And as we can see, we have now the margin as its own and have right top and left, but we have also padding, which we then can use, let's say padding bottom, and we have like 1 rem. This line 18 does compile fine, but if I remove, for example, the m, then this property will no longer compile because the size is not the correct, is not in the correct shape. Now you have maybe seen that here we get an error because we have mapped over these properties, and it tells you, listen, I want you to have every possible combination in this object. And to say we only want to allow certain ones, we can just add a question mark in here, because this says TypeScript not all properties have to be assigned. So this is about the template literals. So next thing we'll talk about is a special type, which I really like to use. How many of you have ever used the never type in their code? Okay, cool. So many of you will learn something new today. Really nice. So first, before we talk about never type, I have to show you a little bit something about conditional types. Like, what are conditional types? Let's say we have a Boolean. Let's call this Boolean or else string. And conditional types always have a generic type which gets passed to them. So let's say we pass in this type t, and now we can create a new type from this generic one we passed in. So we can, for example, say if t extends Boolean, so if t satisfies the constraint of it being a Boolean, in this case, just return the Boolean itself. Otherwise, let's just return a string. Now let's check how this works. We have now this Boolean or else type, and we pass in, for example, a number. And as we can see now, this now creates a new type, the string type. So if I would change this, for example, to true, this would return a Boolean, because true also is like a subtype of Boolean. And if I would put in anything else, for example, Boolean or false, this would show the same. And this is really powerful, because this way we can create new types on existing ones, and like in some ways similar to the map types. So, but let's now go, let's say you have a function, fail on empty string. We pass it in a string, like this, and we say, well, if the input of the string is empty, then we throw an error and say input is empty. Now, this is all fine, and if I call this function here and pass in an empty string, this will not throw any compilation error, because this will only fail at runtime, but because TypeScript is really only usable in compile time, so how could we make this happen that it's not possible to pass in an empty string to this function? So we could do this in one way. We can say, let's create a type, no empty string. And we say we want to pass a type to this type, to this generic type, but we want to say this has to be a string. We can't pass anything to this type which isn't the string itself. And now what we can do is we can say if t extends empty string. So basically if t is exactly an empty string, we return never. Otherwise, we return t itself. Now, what is never really, and why is it so powerful? So let's say we have a string here, and we say hello Porto here. Now, implicitly, this string is this object, this str variable is a string. Now, if I say this explicitly, I say string here, we can see this works fine. But what happens if I change this to never? As you can see, this does no longer compile because string is not assignable to type never. So as TypeScript developers, we know all what to do. We say as any, and this works fine. Beside here, this does not work. And this, when I first thought of this, I thought, well, this has to be a bug in the TypeScript compiler. But this is, as you can see, even any is not assignable to the type never. And why? Because never is like its own. It's like its own type, and it does not inherit anything else. It stays for itself. And now you maybe think, why is this helpful? We will see this exactly right now. Because we have now this no empty string, and we say if t extends this empty string, then we return never. Let's use this in this fail on empty string function. We make this a generic one, and we say we have this t in here too. We say this is a string. Now what we say here is no empty string, and we pass it in our t. And now as you can see, this line does no longer compile, because argument of string is not assignable to parameter of type never. So why did this happen? Let's backtrack a little bit. So we have this empty string we pass in. This empty string is this t in here. And if t is an empty string, then it creates the type never. So basically what happens here now is never. It resolves to never. And because of that, you cannot assign a string to never, so it throws an error at compile time. So of course, maybe you are not using, like, you're not passing pure strings into your functions. You always have them in a variable. But let me show you another possibility where you can use the never type, which I think you will use basically on a daily basis if you're using TypeScript. So let's say we have a type here, locations, and this is either Zurich or let's say Oslo. And now we have a function get country for location, and we pass in our location like this, and we return a string. Now, what I show you, you could also do with if else switch, but I will show you this with a switch case. So we have a location in here, and let me first have our case. Let's say for Zurich, and we say return Switzerland here. Now, TypeScript tells you, oh, you have not covered all the branches. So if I will put in Oslo, it will return undefined, and you only want to have string. So it tells you at compile time, this is not nice. You have to add Oslo too. So let's do this. We add Oslo in here, and we have it like this. And now TypeScript is satisfied. Now the problem in here is, let's say you are like a library author or something like this, and you call, and you also your code also gets called in JavaScript. So in JavaScript it looks always like this, because if you don't create like JSDoc or something like this, then you don't have types. You can pass in anything you like to a function. Now to make this also runtime safe, because while I really like compile time safety, I think it's really important that we also, because TypeScript, all the types get stripped away, that we also have runtime checks in place for like really important parts in our program. So we then say default case here, throw new error, and we say, well, the location is not no. Now this is all fine, and now we have the runtime safety. But now something bad happens, because let's say I have London in here. And now I use London down here, remove this as any, we are in TypeScript again. Then this works fine here, but it will throw an error at runtime because we haven't covered this branch here. So now we have runtime safety, but we don't have compile time safety anymore. So how can we fix this? One way, which was used prior to recent versions of TypeScript, you could say you have like a variable in here, you can call it whatever you like, but the important part is you assign it the type never. And then you say, I want to assign the location to this never type. What now happens is, TypeScript is extremely clever about this. It knows, okay, there are 3 possible branches, but only 2 are covered. So the possibility is that there is this London branch, which then we try to assign to never, and because you can't assign a string to never, this will throw an error. So this code will never compile this way. So this way you have the compile time, but also the runtime safety in place. Because in like JavaScript, this line here doesn't do anything. Now I'm often hearing like, yeah, but now I have this variable here which is declared but never used. Maybe it's in Sonar or something like Sonar Cube doesn't like this. So we can make this, since recent versions, we can make this much more nice. So we can remove this and we can use the satisfies operator. So we can say satisfies here never. And what this does is it basically tells, listen, I want to check that the location type, that the type which is in the location also satisfies this type, the never type, and this never does it. So as you can see here, this does not compile. But if I change this here to and add the London branch, as you can see now, the code compiles again. And this is like a pattern which I use basically all the time in code, so that we have always compile time and runtime safety. We have the default case here which catches all the possible as any calls, but we still have the safety that we don't add something in our types and don't use it in our code. So this is about the never type. So next thing I'd like to show you is about a keyword, the infer keyword. So how many of you have used infer? Cool. Yeah. Almost the same amount, so it's really cool that I can maybe show you something and you can use it then in your toolbox. So what is infer basically doing? So infer is used to extract certain parts of a type and create new types from it. So let's say we have a function. We have a really complex function here which takes 2 parameters, and because it's such a complex one, we only want to have the return type of this function. So how can we do this? Let's say we have our add return here, and TypeScript itself has a utility. So we can say return type. We can pass the type of our add function, because typeof here is not like in JavaScript where you only have like it's a function object or a string or something like this. It returns exactly what type it really is. And because of that, if we now check what's in there, you can see we get number as a return value. So if I change this, for example, to Boolean, then as we can see, this now is a Boolean. So how does TypeScript do this? TypeScript uses infer to achieve this. So let's create it ourselves. So let me show you how this really works. So let's create the myReturnType here. We pass it in any type, it doesn't really matter. And then we say, well, if this type we pass in satisfies the constraint of it being a function with any input and which returns anything, in this case, let's just return any, otherwise return never in this case. So if I now change this here and say myReturnType, this compiles, but we get any back because we have not specified what we really want to return, which type we want to extract. So how can we do this? You can use infer always in a extends clause. So you can't use infer like here at the t, but you can use it inside this extends. So what you can say is if t extends this shape, what you then can say is infer the value at this specific position and save it in a variable. I will save in the variable r, and then we can say we return it. And as we can see now here, this now changed, and now we have the number type extracted from our function. So if I would change this, for example, again to string, as you can see here now, this changes to string again. So now in the next part of the talk, we will use this heavily to when we are working with recursion. So recursion is often a little bit scary, but here in TypeScript they have implemented something really nice, because they only allow a recursion depth of 999, and they won't go further, so you don't like crash the TypeScript compiler. So hopefully this will work today. So how does recursion really work in TypeScript? So TypeScript itself uses it for some of their types. Let's say we have like a nested promise here, and we have a promise inside a promise inside a promise, and in there, like for example, is a sticker type. And we want to have these stickers, so we can unnest them, and we can use the awaited type. This you can pass it a promise type like this, and what it now does is, if we check, this unwraps this promise, this nested promise, and just returns you the type of this nested one. So how does TypeScript do this? It also uses like infer and uses recursion. So let's create one ourselves. Let's create an unwrap array one. and we pass it in a t, and we want to like unwrap a deeply nested array. So how can we do this? Well, we can always think about how would we do such a recursion in normal JavaScript, TypeScript, Java code, whatever you mean. You would just check this type we pass into our function. If this is an array, in this case, go one step deeper into an array, and as soon as you find your result, just return it. And this is basically exactly what we're doing here. We say if t extends array, so if t is an array, we say infer this inner type, this generic type of the array. And in this case, we just call unwrap array again with this inner type. Otherwise, we just return the type, because as soon as it's no longer an array, we want to type. So let's see if this works. We have our nested array, which is an array inside an array inside an array. And there are many stickers. And let's say we want to extract them. And we can now say unwrap array, and we pass it in this nested one. And as you can see now, we get the result back, we get the array type back. This is also, for example, helpful if you're like working with like deeply nested arrays and you want to like have the type from it. So I've used it sometimes, but what I really use often on a daily basis is some more complex recursion, where you like build a type by passing in some information. So let's say we have here our type, we have our RGB tuple. So, and this is just a fixed length array, so a tuple, which means, let's say we have this object here, and we have the RGB tuple, and it's just a fixed length array. So if I, for example, would add a fourth element, then as you can see, this no longer compiles because you can't just add an element to it. But what's important also for everyone who is using tuples is in TypeScript, you could just say push or pop on it, even if it's a fixed length array. So to stop this from happening, just add read only to it. In this case, if you say RGB tuple, you can't use push or pop on it anymore, so you make it a little bit more safe. But this is now really cool and this works fine. But what if, wouldn't it be nice if you, for example, if you're working with like a legacy system and it like returns you like an array with 20 elements and the third one is like an ID or something like this. If you then want to create a type from this, you would have to create a tuple with like 20 elements by yourself and then count it, and this is not really fun. And so wouldn't it be nice if there would be like a tuple type in TypeScript where you can pass how many elements it should have and the type of the tuple, but sadly this does not exist. But the cool part is we can do this easily ourselves. So let's say we want to create a tuple. Now the first element, of course, is the length of the tuple we want it to be, we pass in. The second one is the type, which we want to allow. For example, here are just numbers. And now we have to think about how can we build such a type. We have accumulator where we can just recursively call our function again and then just add more elements to this array. So of course, what you have to do here, we have to have an accumulator, and we say this is an array, an array with these types we pass in. Now what we have to do here is we would always have to add an empty array to start with, but because we don't really want to do this, we can say equals empty array, so that at the start we just initialize it with an empty array, so we don't need to specify this ourselves. So now how do we implement this? Well, the first thing is always in recursion, what is like the exit condition? What is like the condition where we want to stop doing this? Well, this is when we have reached the length which we passed in, and the array, this accumulator, has the same length basically. So we can say length extends, and now you're maybe thinking, but how can I access the length of this array? Now, how would you do this in JavaScript? You could just say accumulator length, like this. Why? Because TypeScript is clever about this. It knows, okay, this ec property is an array type, and so it has to have a length. So as we can see here, we can access this. So if this length extends the length we have in our array, in this case, we just return our accumulated value. Otherwise, we just call our function again. So we just say tuple here. We pass in the length and we pass in the type. And now, how do we add another element to it? Well, we can do this really easy. We can just use it in an immutable way. We can say we have this this array here, and we say we spread our existing types into it, and we add just a new one like this. And this is already it. So if we check here what the result here is, we can see that this still returns a tuple with 3 elements. Now, what we now can do, we could, for example, say there are now 10 elements in it, and it now creates a type with 10 elements. I can also say I want to have it not only a number, but it should also be allowed to be a string. And as you can see, it generates all the possible combinations. So this is really nice if you want to have, this is like just an example how you can use recursion to like build your own types. You can do, for example, also like tree structures. For example, if you have trees and leaves, and then you can say you have like a depth of 10, you can also do this with this recursion. It's basically endless, but as already mentioned, if you check here, you can do this 999 times, and this works perfectly fine. But as soon as I change this here to 1000, Typescript tells you this is not really how it should be done, and it returns any. So you're safe, so you don't crash your machine. But it's funny. Some versions ago they had a hard cap at 40 recursions, and now there are 999. Maybe they will even exceed even more. So, but this is basically what you can do. Now, one short side note here again is that on this tuple now you can again use push or pop, because this is not read-only. To fix this, we can just say we wrap this in a read-only, and as you can see here now this is a read-only tuple, and you cannot use push or pop on it again. So the next thing and the last thing I'd like to show you is about branded types. And branded types are something I think is really important for everyone who is working like is working in an industry who has basically this is everyone. So, but why is this so important? So let's say we have an email here, and let's have my email here. So this email here, let's say you want to send me an email. Let's write a function send email here, and we have an input, which is a string. And now we want to make sure that we only can input valid email addresses. We don't want to handle in this send email address always like, is this a valid email? So what you could do, of course, is you could say you create a function is valid email basically, and you put in your string, and we return a boolean, and we say return input and includes, and this one, and this works perfectly fine. So what we now could do is we could say is valid email here. We pass in the email, and in this case we send email, and we use this email here. Now, of course, you all see it. I can still, of course, do not an email, and this will still work perfectly fine. And the problem here, of course, is that you can't be sure that this input always is a valid email. So wouldn't it be nice if you could, for example, do something like this? If you could say we have a type email, and now we can say, well, we only want to allow to pass in an email here. But as you can see here, nothing really changed, of course, because the email is just an alias for a string. There's really nothing fancy about this. So what can we do instead? Now this is where branded types come into play. Many languages are using like a construct, or for example in Java you would say, now I create like a class which is called an email class or something like this, and then you put in like it's one string like the email, and then you can just pass around this wrapper object and can see, okay, this has to be an email. But the problem is, if you then access this email, you have to like unwrap it, you have to access the properties, and it's really just unnecessary code. So, but we can make this much easier by using branded types. Like branded types are like a feature in TypeScript, but it's like a construct you can create by using some of the building blocks of TypeScript. So the first thing we need to do is we can create a type guard. What is a type guard? We can see this is valid email here. This valid email returns true if this is a valid email. But let's change this. Let's say input is email. And what this basically does is it narrows down the string type to it being not only a string, but also something else. So, and as you can see, nothing really has changed. This line 19 still compiles. But now we do something interesting. We add an ampersand, so we create an intersection type, and we say this is not only a string, but this also has a brand property on it. Let's call this email. So now something interesting happens. As you can see, line 19 does no longer compile. And if you hover over this, we can see argument of string is not assignable to type email because it's missing this underscore underscore brand. Now, when I first saw this, I was thinking like, is this like a magical property or something like this, which I didn't know, but you can just add in anything you'd like. It doesn't really matter. The trick about this is the following, and it's maybe a little bit hard to wrap your head around when you first see it, but what really happens here is we put in here a string. But we can basically put in here, if you would put an object in here with, for example, one element, for example, a property A in it, then you can also put an element in it with A and B or A, B, C, and so on. It just has to like satisfy this one specific type. But it could also, but this way we say, this input is not only a string, but it's also like this brand email. And this isn't really true. But please don't tell Typescript, because it really believes in us that this is an email, because we tell, okay, we pass in a string, but in this case, it's not just a string, it's also the much more narrowed type email, which has this property on it. Now, the cool part about this is here, you can't just create a property yourself with a string, because Typescript tells you this is not possible, because there is this brand object missing. But in JavaScript or in TypeScript, you can't really create them by yourself. So you're like locked that you have to do this inside this check here. But the cool part about this is that out here, this is not, of course, not assignable. But as you can see in here, this email still is a completely normal string. So you have all the properties, all the functions on it like you have on a normal string. So, and the cool part is, of course, let's say you have like another function, which, for example, is called trim. And you have like an input again, which is a string here. You can still just call this function easily with the email. You don't have to like unwrap it or something like this, because it's still just a string. And of course, you are you don't have to just use email. You could, for example, say you have like an ID or an ID type, for example, UUID here. And let's call this UUID, but of course you can call it whatever you like, or you can do this also with numbers. You could, for example, say you have not a string, but you have like a positive number in here, and this is a number, and let's call this a positive number here. And now you can have like a check where you can see that, where you can check if a number is positive, and so everywhere you use this positive number type, you can be sure that that this number is a positive. So this is basically endless. You can make sure that you have like your primitive types also in a certain shape. Basically, like I've shown you prior with this non-empty string, you can also create like a non-empty string type here, and then have a check. And everywhere you put in this type, you can be sure that this really is what you expect it to be. So this is it about the branded types. So before we go to the next part, I'd like to give you just a brief outlook what you could really do if you would take everything I've shown you together. And of course, what I show you now isn't really, you should not really do this in production or use this anyway, but this is something I've written in around 38 lines of code. And what this really does is you have like a validator, and this just takes like a calculator type. And as you can see, this is like the same structure as we have seen with this no-empty string type. And it checks if a given string is a valid arithmetic expression. So for example, if I add here the parentheses at the correct position, this compiles. If I add it at the wrong position, this does not compile at all. So this takes use of infer, of map types, of template literals, of recursion, heavily on recursion. So if you want to check what's done in a much more complex stuff, it's also on my GitHub. Just go into the TypeScript repository, you can find it. there. All right. So let's now go to the questions, if there are any. I have to go other way around. Yeah, exactly. With this, so in the RGB CSS example, how can we have an A, but the alpha is optional? How to map this type? Well, what you could do is, let me try to do this on the fly. So we have like this. Let's let's have it like this, and we have our RGB. And now what we could say is, this is a little bit more complicating. What we could do is, we can say we have like an optional, one like this. Like this is just how it has to be, how it has to look like. And now what we can do here is, we can say it's either, you would have to say like the problem is always with this trailing commas here, because otherwise we could just say it's a number or never in I believe. So, and now we could say this is RGB CSS here, and we could now say RGB and 1, 2, 3, and then we have like another one. But of course the problem is now they are just two numbers. We would have, I think maybe you would have to create like a wrapper type, but now let's take the time and do this. So conditional alpha, and we have this t in here, and we say if t you could do this basically by saying, you then use this in here. It could be either, oh yeah, it could be either like this, no, exactly, it could either be like this or an empty string. And now what we can do here is, we can say conditional alpha, like this. We can remove this here. And now, as you can see, we can add a fourth element. Now this works fine, but I can also remove this, and this also works fine. So this is like the conditional type which we could use. So, sorry? Yeah? Yeah, you could do this. You would then have, maybe. But what you could do is, maybe you could do it like this. I have never thought about this, but let's check if this works. Yeah, this works fine. Yeah, this works fine. So you can say it's either 2 or 3 elements. Really cool. I will put this in my talk. That's really nice. Thank you. Really nice. So in the no empty string, can't we make the type error more explicit? It's the empty string that's problematic. Yeah, I think this is not possible because we would have to like create our own string or something like this. I've done this in the calculator example, but here I think we just want to have to see an error on the. I think if we have this function which speaks for itself, fail on empty string, then you can see it. But maybe you can do this, but it's then not really that. How should I say? It then creates like a string as a type. It's a little bit complicated, but you could do this. But I think it will, in this case, will not work. What's the difference between marking a type as read-only or as const? Yeah, what he means is that what you can do here is, instead of doing the as const here at a, sorry, where are we? We are in the, yeah, doesn't matter. Let's say we have this tuple here. He means that you can say we have an as const. This is also in recent versions where you could add this, but I think you can't use this as a type. You can only use this as if you use this as an object. So if you have an object, then you can say this is like a fixed length, not just any array length, but a fixed array length. Exactly. So let's check if there are more questions. Are there any questions which aren't there? Just yeah, exactly. Yeah, exactly. Of course, yeah, exactly. So you could, of course, also just make it like this. You could say it's just an RGB CSS, or it's a one with 4 elements. Exactly. You could also do this. Yeah. No. No, I don't have to say no. You can do it, but it's then with recursion in it, and it's extreme. It creates extremely large elements. So what's maybe more, what would be better is that you like have a string, and you parse the string if it's from 1 to 225, but it's all 255. But it's really not. That's where even I would stop doing that, because this is just way too. Nobody could read these types anymore, and I think this is Okay, I think we are on the end. I really want to thank you guys for being here. If you want to get in contact, scan this QR code or on Twitter. And thank you for being here. Wish you an awesome rest. Thank you.